Let's sketch the solid and then find its volume. We'll start with y equals x squared. That's just your basic quadratic. We know that 0, 0 is a point, 1, 1, and then 2, 4. And then we have y equals 2x. We can draw this line by, again, point plotting. 0, 0 is a point, 1, 2 is a point, and then 2, 4 is a point. So we have this line. We're next going to rotate this along the y-axis. So that's going to push this curve over here. And that will give us this shape. Notice that when we slice this, we're dealing with a washer this time. To set up the volume, we're going to take the integral from 0 to 4, looking at the y direction, and then the area times dy. Now notice this time we're not dealing with a disk, we're dealing with a washer. So to find the area of a washer, we're going to do pi times the outer radius squared. Then we'll subtract the pi times inner radius squared. And that will give us the area of that washer. So continuing our integral, we have 0 to 4. To find that area, we have pi times the outer radius, which is the square root of y, because this equation is y equals x squared. Solving for x, we would get the square root of y. And then minus pi times the inner radius, which is y over 2. And that's coming from y equals 2x, that line. If we solve for x, we get y over 2. Simplifying this, we have the integral from 0 to 4 pi times y minus 1/4 y squared. Now we can integrate. We'll pull pi outside. This leaves us with 1/2 y squared minus 1/12 y cubed, and we will integrate from 0 to 4. Next, we'll go through and plug in our upper limit, 1/2 times 4 minus 1/12, 4 cubed, minus, plug in the lower limit, 1/2 times 0 minus 1/12 times 0 cubed. Simplifying all of this, we get 8 pi thirds. That is the volume of this solid.